Hi, this is a presentation of our paper titled "We'll Fix It in Post. What do bug fixes in video game update notes tell us?" This is a joint work between the University of California, Irvine and the Federal University of Bahia. So the motivation for our work stems from how games releasing with bugs can cause significant problems for game developers. These problems can include anything from bad publicity, poor sales, and even lawsuits. As a recent noteworthy example, the Cyberpunk 2077 game that released last December had such severe bugs when it came out that the game was removed from digital storefronts, and the developers suffered a significant drop in their stock price. So the appearance of bugs in video games might be explained by differences between game development and development of more traditional software. And prior research has looked into some of these differences. One difference is how games typically have less strict functional requirements as opposed to being designed to accomplish a specific task. The central requirement for game development is more along the lines of, is it fun? Additionally, game development is likely to involve more diverse teams in terms of background and expertise in the team. For example, you're likely to see more graphic designers and artists in a game development team. And then finally, games have particular difficulties related to testing. With games, there can be a larger possible number of user interactions in the game space, for example. So one way that developers address previously undetected bugs post-release is by applying updates to their games that fix these bugs. These updates are usually accompanied by update notes, which are textual descriptions of the changes that the update is making in the game, including a list of bug fixes. So our initial question was, what types of bugs are being fixed in these updates? In addition, not all bugs are equal. Some are easier to fix than others, and some may cause more severe problems for players. So one aspect that ties into the difficulty of fixing bugs is recurrence. And this refers to instances in which a bug is said to be fixed in an update, but then that same bug appears in a later update, suggesting that either that bug wasn't actually fixed the first time or something that happened in that game since that bug was fixed has caused it to reappear. And then one sign that a bug is having a severe impact on players is when a bug is fixed in an urgent update. An urgent update is an update that is pushed to quickly resolve bugs that are more likely to have a severe negative impact on users. And prior research has focused on metrics for identifying urgent updates. So for our research, we found prior work has created a taxonomy for bug types that appear in video games. These bug types in this prior work were identified by watching videos of gameplay and reading articles related to user bug complaints. However, it seems that they might have missed more subtle bugs that might not have been as readily noticeable. Things like background variables that might not be visually apparent to the player. So for our research, we expand on this prior taxonomy and applying it to the bug fixes that appear in update notes and updating the taxonomy as necessary, with the general goal being that a robust bug type taxonomy will help identify the association between different bug types to different game development techniques and processes. So our three research questions were, what are the most frequently fixed types of bugs through game updates? What are the most frequently recurring types of bugs? And are all types of bugs equally severe and negatively impacting the game experience? So now I'll go over the methodology for our research. So here I'll go over a high-level overview of our process. Due to time constraints, I won't go into the details of everything we did, but here are the basic steps that we followed. So the first step involved data collection. We collected updates for the 30 most popular games that are available on the Steam platform, with popularity being determined by the games with the highest number of players on June 23rd, 2020, which was the day that we began our data collection. So for each game, we collected all update notes in the 1 year period leading up to the date of the game's most recent update. The next step involved categorizing the bug types in these update notes. So this initial taxonomy from the prior work was comprised of 11 bug types. And through this categorization process, we ended up adding 9 more bug types after examining these bug fixes in the update notes. And we manually labeled bugs in our data set based on the core impact of the bug in instances in which a bug could feasibly fall under two or more categories. So as an example, one of the bug fixes mentioned in the update notes stated, fix the issue where running left or right was impossible when transformed into an immortal persimmon knight. So one aspect of this bug relates to the incorrect position of a game object over time, which was one of our categories. what we felt that the core impact was in the player's inability to perform an action. And this action label was another one of our bug types. So we ended up applying the action label over the position of object label for this particular bug fix. So the next step, we then analyzed the bug types with respect to how frequently they appeared in updates, their recurrence patterns, and their severity ratings. We also surveyed a body of game developers on their experiences with these bug types and asked them about processes of game development that they associated with bugs. We received 47 applicable responses. And overall, we examined 723 game updates and 12,122 bug fixes. And in the next slide, I will go over the results of our work. So with respect to frequency, the most frequent bug types in the update notes were information, which relate to the information given to the player, game graphics, which are errors in graphical elements of the game, and this bug type relating to player inability or ability to perform actions. We also asked survey respondents for their explanations on why they believe these bug types were so frequent. Explanations included how with information bugs, they were seen as low priority, for example, compared to other bug types. Game graphics were one of the reasons was complexity involving game graphics, large size of the testing state space. And with action bugs, there again was large size of the testing state space, increasing complexity with additional possible actions was another explanation. So with respect to recurrence, we found that the most frequently recurring bug types were crash bugs, game graphics, and triggered event. Crash bugs are bugs in which the game is forced to close or otherwise becomes unresponsive. So when we asked the survey respondents about explanations for these bug types having high recurrence, for crash bugs, explanations included difficulties in reproducing bugs, reappearance of the bug after other changes. Game graphics, explanation included interdependence of graphics, unforeseen edge cases, and for triggered event bugs, again, large size of the testing state space was given as a reason. So for severity ratings of the bugs, we took the severity rating was determined by finding what proportion of these bug types appeared in urgent updates. So basically the frequency a bug type appeared in an urgent update over the frequency of that bug type overall. And we largely used metrics from prior research to identify urgent updates. And the bug types with the highest severity ratings from the update notes were crash bugs, object persistence bugs, and triggered event bugs. So in the survey, for each bug type, we asked survey respondents their level of agreement that each particular bug type is likely to have a severe negative impact on the game experience for players. And from the survey, the most severe bug types that we got were crash, action, and exploit. So from these results, we can see that crash bugs had the highest severity rating in both the update notes analysis and from survey respondents. Meanwhile, the survey respondents had cited exploit as one of the top severe bug types, but this was the type with the lowest severity rating from the update notes. So we have some ideas on how to explain this disparity, but this could also be an avenue for future research. So now I'll go over some of the implications and possible avenues for future work based on these results. So one possible avenue for future work relates to prioritization of bug types. Researchers and developers can focus on devising methods to address the bug types that had high frequency, recurrence, or severity. For example, as we saw, crash bugs recurred frequently and had high severity ratings. And then another area of interest connects to the game development process. Our survey asked respondents about aspects of game development associated with bugs, and answers we got included testing, issues with game design and code quality. We also asked about challenges in identifying and fixing bugs in video games, and responses included inadequate testing, difficulties in reproducing bugs, and code quality. So researchers and developers can devise tools or approaches to address these aspects that may, in the end, help mitigate the presence of bugs. For example, application of multi-component interaction testing could improve testing processes. So this is the end of our presentation. Thank you for listening, and we will be happy to take any questions. Thank you.
So welcome back to the live part, to the live Q&A of this game session. We have now here the co-authors of the third paper with the title "We'll Fix It in Post." What do bug fixes and video game update notes tell us? And we have a little bit less than 10 minutes for your questions. So I will start with one question from Sebastian. Very well done, Sebastian. So what he says is, from the motivation, it seems that the focus of game development is much more on non-functional requirements, like fun or looks nice, different from graphics glitches. Would problems in this area also appear as bugs, or would they show up in other parts of the development cycle? So, Andrew?
Yeah, so
just one thing, Andrew, can you share your camera, start your video, because we don't, now we see you again. Okay, thank you.
Okay, yeah.
Yeah, that's why it's much better.
Okay, sure. Yeah, so looking at the question, so the non-functional requirements, whether it's fun or whether it looks nice. Yeah, so I guess part of that is, so some of these bug types that we looked at, I guess you could split between functionality related bugs and non-functionality related bugs. So bugs that were related to performing an action, I guess you could say, are functionally related. If a player is unable to perform a task, then that's sort of interfering with that functional component of the game. But things like the game graphics bugs, they're not really inhibiting gameplay necessarily. It could be that there's, a character model doesn't look right, or they're wearing armor that doesn't fit the character right, or there's clipping between graphical assets to where they might not necessarily interfere with gameplay. So I guess even within games, there's still kind of this distinction between bugs that are, more functional related and non-functional related. Does that help with your question?
So while Sebastian replies through the chat, I will ask in the meantime one question which I got here. So you say at the end of the presentation that tools that help in the process are required. So we have the typical development tools. I mean, I'm thinking now at GitHub and so on, but probably they are not well suited to game development, especially for the type of games you are looking for. What type of tools, or how should these tools be? What are the differences of that? You just cannot say take GitHub. So what should be done? How should these tools be?
Right. So I think one thing that we noticed was that for in games, one of the big differences between game development and development of other software is the difficulties in testing, where there's not really a great range of automated testing tools. A lot of testing is done manually by human play testers. And one of the reasons is because of this, large state space and the large number of possible inputs that users can give. So I think there's room to explore improving automated tests and automated test environments with games. And there's also room for maybe integrating testers into other parts of the game, maybe get them involved a little earlier than what it seems like a lot of game development processes do.
Okay, so if you read that Sebastian's comment, it goes a little bit in line with my question. He says, maybe what you don't need a backtracking system. You just need to look at social media and look at Twitter, what your users are reporting. Mm-hmm. Do you know if companies are doing that? Would it help?
Yeah. So some of these some of these non-functional issues, I guess you're saying, would not necessarily be reported as bugs because users might not necessarily see them as bugs. And I think that's fair. When going through these updates, there's this distinction you do have to make where when you're looking at changes to the game, you have to ask, is this actually a bug, or is this just a change to the game, the rules of the game that would make, with the purpose of making it more fun? So if you look at, I think the game Overwatch, I saw in the news like earlier this week that the game had been 6 players versus 6 players. That's how the gameplay was set up, and they announced this week that they were changing it to like 5 players versus 5 players. And that's not necessarily that there was a bug having 6 players, but it's more a change to gameplay rules. That might not be the best example, but issues in which rules are changed, or time limits are changed, or let's say game balancing. Let's say such and such character is too powerful, they do too much damage. Let's adjust that and make them do less damage. It's not that the character doing too much damage isn't necessarily a bug, because it's doing what the developers designed or intended, but it's not, they're finding out that it's not the most fun thing. So whether I wouldn't be hesitant to classify that as a bug. And so when it comes to players reporting issues to developers, I think that kind of thinking might be something that keeps players from going to social media as opposed to leaving a bug report, because their thinking might be along those lines of, I don't want to report this because I don't think it's a bug. I'll complain about it on Twitter, but I won't report it.
Yeah, there's a clarification question there from Sebastian. So what you have investigated is the differences in update notes between early access channels and updates after release, or what are these the update notes? Could you explain a little bit better the process, what you've looked at?
Yeah, so we didn't differentiate between update notes between early access channels and after release. I don't know for certain, but I don't believe any of the games that we examined were in early access. But no, we didn't differentiate between early access and post-release updates.
Okay, so we have another question from Amir, who says, do you think that major games like Dota 2 on Steam may skew your findings a bit? And he says this because this kind of game gets frequent updates compared to a typical game.
Yeah, so it's possible. It's entirely possible that the sample that we included, some games might be more dominant than others. With Dota 2, I found that with the time frame we used in collecting updates, the number of updates it had was on the higher end, but not necessarily that much higher than the other. It wasn't like an outlier as far as number of updates go. And at the same time, we did find, this is just from our own experience as we collected these updates. We did find that in cases in which games that had more frequent updates versus games that had fewer updates, there might have been some balancing out, in the sense that more frequent updates had generally tended to have fewer bug fixes, where there were plenty of games that had fewer updates, but the list of bug fixes, which was much longer. So, it's entirely possible that some games might skew the results more than others, but it seemed like on a general level, there was a sort of a balance going on.
Okay, so thank you. Yeah, Amir says, thanks for the answer. So we have 1 minute to go. So one easy question at the end. What are the next steps in your research? What would you like to do next?
Right. So we're looking at the, I guess, when it came to those aspects of game development that are that these survey developers associated with the appearance of bugs, we're looking at exploring some of those game development processes and seeing what types of tools or approaches we might be able to look at developing. I know I've only got 30 seconds left, but I guess I'll say we've been looking at the bug reports, specifically the issue of bug reproduction, and looking at examining the content of these bug reports, seeing what kind of information is there. And
so just one thing that you have, then when it finishes, we have the discussion room. You can join us, and you will see a pop-up shining up, and then just press the button, and Andrew and his co-authors will be there. I will be there as well too. Thanks for joining. See you in the discussion.